So that's what we were discussing, right? The welding, the defect of undercut or underfill. Basically, it is not filling or not basically not filling the weld area properly. The weld is not able to fill the gap properly, the gap between the two base metals, right? So what are the causes of it? It could be faulty electrode manipulation, right? The welder is not able to, or for example, if it is automated, you're not able to have, manipulate the electrode. What do you mean by manipulation? Basically, to be able to move it, right, precisely, left and right, and with what speed, and what do you call, if it is movement of the workpiece, if it is movement of the electrode, it depends. Sometimes the electrode is stationary and the workpiece moves like that. So you have to have a manipulation of the electrode properly. You should be able to move it as much as you want, right? As exactly as you want. You should have control over this electrode movement. Faulty electrode usage, the electrode chosen is not proper. That means, for example, the heat that was required, or you can say, the electrode size is less, for example. The diameter of the electrode is less. So therefore, it is not able to fill the gap properly. That could be this faulty electrode usage, or it could be that you are not using a proper electrode that was required for this combination of the base metals, right? A certain amount of heat or material was required, which is not able to be supplied by the electrode. So that, and current is too high. Even this comes off as a problem when the current is too high. But the cures, you can use uniform weave in butt welding. Basically, we know what is weaving, right? So you move in zigzag way, like this, weave it. So this will avoid this problem, that this gap is there, right? So when if you have observed, the welder tries to move left and right, oscillates. He moves his hand left and right. Basically tries to weave it, right? Stitch it, as we do it in the case of tailoring, or if the doctor is applying that stitch. So that is the same principle that you can use here to avoid this kind of problem, right? Avoid using an overly large electrode, right? Even this is, as for the electrode, avoid excessive weaving. Even excessive weaving will do, what do you call this? We'll have this problem. And because the heat is not able to focus on one spot, right? That is a problem. The heat that you are giving, that is generated, is not able to focus, because you are trying to move it more and more, and therefore it is not able to generate the heat properly. Use moderate current or weld slowly. This is another way to do. Current could be kept moderate, and if you do the weld slowly, then this will fill up like that. Hold electrode at a safe distance from vertical plane in making horizontal fillet welds, right? So from the vertical plane, you have to maintain a safe distance when you are trying to make a horizontal fillet weld, right? When the workpiece is kept horizontally. So that's what is meant here. Another thing is distortion, right? So in case of warping, it was what do you call, a kind of curvy shape, right? It was warping. Here, this is complete distortion, in the sense it will also, what do you call, what we can say, it shifts the angle as well. There was curvature there. Here you are having this kind of angular misalignment, right? Uneven heat is one thing. Improper sequence, and deposited metal shrinks also. The shrinkage, as we have discussed. What are the cures? How to avoid it? Tack or clamp the parts properly, right? Just as we have done for the warping case. You can clamp them properly to avoid this kind of defects. Form parts before welding. Basically trying to prepare that edge preparation. dispose of rolling or forming strains before welding, right? So you see, we will get to this topic in the third unit, that because of certain mechanical operations, certain mechanical processes like rolling is one process wherein you're trying to roll the sheet metal, right? For example, if you want to decrease the thickness of the sheet metal, you move them to in between two rollers. Just as in the case of a sugar cane mill, if you have seen, that tries to compress, right, the sugar cane. Similarly here in rolling, the same thing happens. Basically, you're trying to roll sheets, right? So that or any other forming process will have some strains, right? Those strains, if they're not relieved, or if they are not, what do you call, in another sense, relieved is a proper word to use. If you don't, if the material does not let go of it, if you not make it to let go of it through other like heat treatment process or any other process, then that will also cause problems. Those strains which are there already, rolling or forming strains, they will cause problems as distortion when you're trying to weld them, right? Because there are stresses inside, residual stresses because of those initial processes, mechanical processes. Examine the structure and develop a sequence, right? To avoid this improper sequence, you can have a proper sequence of how to weld and where to weld, etc. Cracked welds, right? As the name suggests, cracked welds. Wrong electrode, this is one problem. Weld and part sizes are unbalanced, right? You have to make a proportion out of it based on the part size. The weld has to be done properly, otherwise it will lead to cracking, right? Faulty welds, faulty preparation, as we have discussed, rigid joints, right? So if the joints are too rigid, then they won't allow for any kind of deformation, and therefore this will lead to we can call them rigid joints in that sense, and that will lead to crack. How to avoid, design the structure and welding procedure to eliminate rigid joints, right? Proper guidelines. Heat parts before welding. So to avoid those cracks, etc., one thing you can do is you can preheat, right? Heat parts before welding. Preheat is what we can call it. Avoid weld in string beads. Basically, you have this terminology in welding called beads, right? So that is to be avoided. Right? And keep the ends free to move as long as possible, right? Ends, right? What we are starting and ending like that. Keep ends free to move as long as possible so that this stress concentration that is happening will not lead to cracks. Make sound welds of good fusion, right? Work with as flow and amperage as possible. Basically, ampere like as in current, right? Poor appearance. It doesn't look good. So how will it affect? Basically, what are the cues? Causes. Faulty appearance, overhang, improper use of electrodes, wrong arc and current voltage. All these are reasons, because in that arc welding we are kind of supplying a power through a power source. We are trying to what do you call it? Provide the flow of current, and that is responsible for generating the heat, etc., etc., etc. So if the arc that is generated is not correct as per the material and the thickness, and the voltage, basically that voltage itself has decided the arc, like you can see in that sense. So that will lead to this poor appearance, right? What are the cues? Use a proper welding technique, avoid overheating, use a uniform weave, we will discuss this, avoid over high current, right? Moderate current is to be supplied. Poor fusion, right? If you're trying to weld two metals, it is not fused properly. We can see in the right side. So wrong speed, this could be one cause, right? Because the speed that you are doing, at which you're doing the welding is quite high. And therefore, it is not able to properly melt the portion which was desired to be melted. Current is improperly adjusted, faulty preparation, right? The edges are not prepared properly in the proper geometry. Like for example, V shapes here in the sense of, in the case of this, probably a V shape edge was done, right? Improper electrode size is another factor. How to cure that? Adjust the electrode and V size, as I've told you, right? For this preparation thing, that V size is to be done properly, and you can adjust the electrode. V must be sufficient to melt sides of joints, as I told you, going from left to right oscillation, right, of the torch or the heat source, basically. So that must be sufficient to melt the side of joints, otherwise it will lead to improper joining. Proper current will allow deposition and penetration, isn't it? Current supplied is very important. That's why we have discussed one factor, different factors in arc welding, right? All other types of welding. That the current was one factor that was deciding the heat that was generated, the amount of, based on the amount of thickness, etc. Keep weld metal from curling away from plates, right? So basically that you will have that top portion, right? So that if it curls away, right, like kind of a curve shape. So if that is avoided, then even you can solve this problem of pure fusion. As for brittle welds, you know what is brittle weld, right? You studied in this mechanics of solid or solid mechanics. The subject is known by different names. So brittle in the sense it will not allow much deformation before failure. That's the simple definition. Ductile is one which allows more deformation before failure, and a brittle material does not allow much deformation. It breaks suddenly. Incapability of the material to take the stress and breakage is what happens in brittle materials. So those kind of welds, basically they will fracture, as simple as that. Causes of it, the wrong electrode is used, faulty preheating, right? As I told you, if you preheat it, this will not come off as a sudden increase of temperature. When you are trying to supply the weld heat, right, out of any other source, electrode, arc, right, or it could be that laser. We have discussed all categories, right? So if the preheating is not done, right, then that temperature will try to cause this increase of temperature here. The rate of increase of temperature is quite high. If it is quite high in any region of the weld, then that will lead to crack, isn't it? So that is what is meant here. Faulty preheating. Metal hardened by air. It hardens by air, right? So a quick solidification, right? That's what is another cause. What are the cues? You preheat a simple 135 or 260 welding on medium furnace. Depends. The temperature depends on the material, right? Each material is having different melting point, and therefore that will decide the preheating temperature. Make multiple layer of welds, right, if possible. If the weld thickness is too high, you can make multiple layers. Anneal after welding. What is annealing? We'll discuss in third unit. It's basically a heat treatment process wherein you increase the temperature of the metal and try to decrease or try to, if it is done in a furnace, for example, you increase the temperature, the furnace heat will try to increase the temperature of the object that is kept inside. And after that, once you put off the furnace, right? The furnace is put off, and what you're doing is you're allowing it to cool down inside the furnace, right? So that's annealing. So that will release these stresses. So that is what this brittleness will reduce if you try to anneal it before welding. Increase the temperature and cool it in the furnace itself. That another thing is use stainless or low hydrogen electrodes for increasing the weld ductility, right? If you want to increase the ductility, you can use either stainless or low hydrogen electrodes. Spatter. What is spatter? Basically, that weld, the weld metal which is melted, it is spattering, right? Throwing here and there, right? So that is what is called spatter, right? Or you can even call it scatter, SCATTR. That is another way to define it. That it is distributed. The weld metal is so fluid, it has become so fluidic, right? Completely melted, right? It is liquid now. So that has no control and it is flowing here and there. So that is what is spatter. You can see here that weld metal has been thrown everywhere. What are the causes of it? Arc blow, right? The arc is too high. Therefore, with that blow, the liquid metal is flowing. I mean, it is basically getting dispersed. Now, current is too high. This is another factor. If the current is too high, heat is more heat, more the fluidic nature of the weld metal, and therefore it would tend to spatter here and there. Arc is too long, right? You're moving very slowly basically. The weld torch is being made to go so slowly that the arc is too long, right? The arc that is generated stays too long at a particular weld location. That is also responsible for weld spatter. Faulty electrodes, right? The electrodes selected are not having that desired melting temperature, what you require for the base metal. Improper combination of electrode and the base metal, that will also lead to spatter. How do you cure it? You whitewash the parts. Whitewash the parts in weld area, right? Adjust the current to needs, right? Proper current is to be used. Proper arc length is to be done. Lighten the arc blow, right? Pick suitable electrodes, right? All these are things basically countering the causes. If you can avoid those, then that comes off as a cure, right? Now, I think, yes, 2 more slides and then we can finish off these effects of weld, right? Magnetic blow. This is another welding defect. Magnetic fields cause the arc to deviate from its intended course. You see, the magnetic field, because of any other reason, we are trying to use current, right? That will also induce magnetic field, or it could be because of any other source, right? That is kept near to the weld area. That will cause the arc to deviate from the intended course. So that comes off as a defect. Cures, you can use steel blocks to alter the magnetic path around the arc, right? Divide the ground into parts. Weld in the same direction the arc blows, right? Basically, this arc blowing concept, I believe I should do one slide to explain that concept. Use a short arc, right? That is another thing that we can do. Locate the ground properly on the work. So, because this is happening because of current and magnetic fields, right? Basically, magnetic fields. So, you can use proper grounding techniques, right? Locate the ground properly on the workpiece. Because we told that we have decided that one would be a positive one, charge, and the other would be a negative charge. Basically, the workpiece is made as ground, right? So you have to locate the ground location properly on the workpiece. And the last thing is weld stress, right? Now, what are the causes? Faulty welds, faulty sequence, rigid joints. So weld stress is something that is not really desirable when it comes to design of the designing it. When you're trying to design any component, you will try to ensure that the welds which are done inside the component, right? Because the complicated component was not possible in one go, and therefore you're trying to make simple components and weld them later on. So that will lead to these weld stresses, right? The welding of it. So what are the cures? Allow parts to move freely as long as practical, right? So you should not restrict movement as much as possible. Make as few passes as possible, right? Because one pass is really going from left to right. This is one pass. And then start again, second pass, like that. Pin deposits, anneal according to the thickness of the weld, right? Depending on the thickness of the weld, annealing is to be done. The annealing time is to be decided. move parts slightly in welding to reduce stresses, right? So even that can be done to reduce the stress buildup in the weld area. So this is the last topic in second unit, that is destructive and non-destructive testing of welds, right? We'll see that in the next class hopefully. Okay, then if you have any doubts, you can ask. Otherwise, we'll end the meeting. Okay, then end the meeting. Thank you.